and welcome to Relative Frequency. My name's Tuesday Johnson. Here's an introduction to concept with applications. So let's start talking about what the definition of relative frequency is and looking at the notation. When an experiment is conducted and the results are recorded, the relative frequency, or estimated probability, of an event E is the number of fraction of times that the event E occurs divided by the number of trials n. And we have this formula. The estimated probability, or probability of E, P of E, is given by P of E equals FR of E divided by n. FR of E is the frequency of the event E, n is the total number of trials. So in this particular English United Kingdom classroom, 35 students were asked about their favorite color. 8 students responded that red is their favorite color. So the probability of a student having red as a favorite color in this classroom is 8 divided by 35, the 35 children that they asked. The table below shows the race and ethnicity breakdown for the UTEP student population in 2021. Please note this is not the entirety of the student population. There are so many subcategories that I had to cap it somewhere. I went with these ones. We're going to create a frequency distribution for the data. Don't overthink this. How many American Indian or Native American students were there? 45. How many total students are we considering? 23,306. So we form the fraction 45 divided by 23,306. For Asian, 236 divided by 23,306. And we can fill all of these in the exact same way. I like taking my decimals to 4 decimal places routinely. If I'm doing homework, I pay attention to what the question asked me for. But I'll frequently go to 4 decimal places, and what should happen, notice how each of these is pretty tiny, except for 88% Hispanic, one of the biggest Hispanic serving R1, D1 schools in the country, just saying. There's also a few white folks, right? They're next in line as the most numerous. And these all should round up to be 100%. It should round up to be 1. I did put ish here. It's a wishy-washy ish. Because of rounding, we might not be exactly at 1.0000. It could be off due to rounding in between, but for the point of the problem, it's 1-ish. Alright, that's it. A frequency distribution just takes the number observed divided by the total, makes the fraction out of it, and then 4 decimal places or whatever is required by your problem. Okay, so let's look at some properties of relative frequency distributions. We're going to let S be a sample space consisting of S1, S2, blah, 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 through Sn. So that's our sample space, and P of Si is the relative frequency of the event Si. So this is the probability that one of these little sample space items happens. Maybe we're flipping a coin. Maybe not. Whatever your sample space experiment, whatever the experiment is that you have a sample space for, the probability of each individual item in the sample space has to be between 0 and 1 inclusive. Probability of an item could be 0. Probability of an item could be 1. Probability of flipping a coin and it landing, just landing, not hanging out in the air, that's 1 because we have gravity. Probability I flip a coin in the air and it just hangs there indefinitely, that's 0 because same reason, we have gravity. Not only is every individual probability between 0 and 1, but if you add up the probability of everything, it should be a total of 1. And we saw that in our chart on the UTEP student population, right? All of those probabilities added together of those individual items, or ethnicities in this case, the probability should add to 1. If we have an event E, consisting of items, little events, the probability of the event E, we add the probability of each item in the event. Lastly, if P of E equals 0, we call E an impossible event. I'm not even using laser pointer, just a regular pointer. How rudimentary of me. And I have a misspelling here, a little typo. We call it an impossible event, not and. My finger just likes to type that word, I guess. Okay, so according to a 2019 report from FIFA, the governing body of international football, or soccer here in the US, professional players are in the greatest numbers in the 4 countries listed below. Mexico has 9,753 players, Brazil has 9,177 players, England 5,935, while Argentina has 3,920 players in international professional football. How many players are represented in this chart? We always need to know our total. So we'll add up the totals from all 4, and we find that there are 28,785 athletes represented in this chart from these 4 countries. What is the probability that a player will be from Mexico? Well, the number observed, 9,753, is our frequency that a player is from Mexico, divided by the total number of trials. The number of trials is the total number of players, 28,785. And we find that a little over a third of the players internationally out of the top 4 represented are from Mexico. What is the probability that a player is from South America? That should have been a capital S, but we're not going to get on my grammar again. South America in this table is represented by both Brazil and Argentina. Mexico is considered a North American country. Central America for some, but I think that's ridiculous. And England is the only one that's not in the Americas, but with probably the South American, 9177 plus 3920. Each individual probability, right, frequency added together to give us a total of about 45% of the top 4 represented countries being from South America. It's a mouthful. So what's the probability that a player is not from Europe? Well, I could do this in 2 different ways. If they're not from Europe, we're going to exclude England. So I could just add up 9753, 9177, 3920. But don't forget, right, we have complements. What about E complement? What is the probability that a player is not from Europe? That's 1 minus the probability the player is from Europe, right? Not is the opposite. It's always 1 minus. It's all the rest. So the probability that they are from Europe, it's only England in this particular example, we'll have 1 minus 5,935 divided by 28,785. And don't forget that 1 can be rewritten as a fraction with the common denominator. And we find that we have 22,850 of the top 28,785 players in international football. So 79.38 or 0.7938 is the probability that a player from here is not from Europe. And that tells me that England carries about 21, a little less than 21% of the number of top professional international soccer players. Still a mouthful. Look at that. Thank you very much for watching. Be sure to subscribe to Math with Tuesday on YouTube. Let's see if I could correct some grammar errors here.